As we saw in the previous example, change in temperature affects the change of length, but there's also the change in volume, which when we're dealing with fluids a lot of times will occur. So the change in a volume is given by the bulk modulus times the original, or the bulk thermal expansion coefficient times the original volume times the change in temperature. So very similar to what we saw with the length, but now we're dealing with volumes instead of lengths. So if we're looking at a change of for the glass and mercury, then we have to find what the change for mercury is minus the change in the glass, and that will give us the overflow of the mercury. And so this is the bulk modules for mercury times the original volume times change in temperature for mercury minus the bulk modules for glass, original volume, change in temperature. And because the volume of the glass was filled to the brim, then the volumes are the same, and because the temperatures were the same, the change in temperature would be the same. So this is the same as the original volume times the change in temperature times the change, or the difference, between the bulk modulus between the glass and mercury. Now, the bulk module itself for glass is going to be 3 times the linear expansion coefficient for glass, and the bulk module for mercury, we can read that from the table as 18 times 10 to the minus 5 per degree Kelvin. So now we can say, okay, we have an original volume of 200 centimeters cubed, and since we're only looking at a change in volume, we don't have to change this to meters. We have a change in degree from 20 degrees to 100 degrees, which is 80 degrees. Kelvin we can put because it's the same. And then the bulk module for mercury is 18 times 10 to the negative 5 per Kelvin, minus, for glass, we said it's 3 times the coefficient of linear expansion, which is 0.4 10 to the minus 5 per Kelvin. If we do that, we get that it's going to overflow by about 2.7 cubic centimeters.